Good evening, everyone. I'm Kriti Bharti. I'm a senior product manager with Amazon Web Services. And today I will be talking about how you can use Amazon Textract for business process automation and document understanding. Presenting with me today is Adrian Lam, who leads AI projects at Change Healthcare. In this session, we will give you an overview of Amazon Textract, its features, its benefits. We will cover some new functionalities and new features. We will dive deep into some of the technical details. And finally, we will see how Textract is being used at Change Healthcare. What is Amazon Textract, and why is it important for document understanding? Let's start at a high level of what we call the AWS machine learning stack. At the first layer, you have the machine learning frameworks and infrastructure that enable you to push the boundaries of what is possible with machine learning today. Next, you have machine learning services, our SageMaker platform, that enables scientists to train and manage machine learning models. And finally, you have AI services, which allow customers like yourself to incorporate machine learning in your applications. And this is where we are today. Amazon Textract is a machine learning service that enables you to extract text and data from your documents for document understanding. Amazon Text reads these documents just like a human being does, without requiring any configuration or any templates, be it financial documents, healthcare documents, government documents, legal documents, and many more. You can read these documents using our simple APIs, just like any human being would. Now, I don't need to tell this group why reading documents is important for business. But let's spend a few minutes talking about why it is challenging to read documents at scale. Well, first, it is slow and error-prone. It is difficult to capture relationships that exist between the various data elements in your document. It is difficult to capture the different types of data that exist within your documents. There are variations between what are seemingly similar forms, but are not really from a document understanding perspective. And finally, there is distortion between the time a document was created and how it was captured. Because of these challenges, the traditional approaches force major trade-offs. If you want human beings to read all your documents, it is expensive, it takes time, and it is still prone to errors. You can also use traditional software techniques, what is known as optical character recognition, OCR, which works fairly well for simple documents. But it outputs only words and numbers. And if there is any structure present in your document, then it does not do so well. There are also extensions to OCR that apply business rules and visual templates to isolate information on a page. But these templates are brittle. They don't work when the form changes over time. They don't work if there is a variation in the document type. And they don't work when the image is captured at an awkward angle. Additionally, there is significant management and development overhead to maintaining these templates. Amazon Textract does it better. Amazon extracts text and structured data from virtually any document. The three different types of data elements that we extract are text. We extract tabular data that is organized into rigid rows and columns, and then form elements that is also structured data, but not organized in rows and columns. Let's take a quick example. This is a seemingly intimidating document which is common in the insurance industry. Let us see the different kind of data elements that is present in this form. First, we have dense text. Text that explains the purpose of this form, how to fill it, and what to do with this form once you have filled it. Next, we have table, data that is organized into strict rows and columns and structured like a table. We also have forms that is also structured data, but not organized in a tabular fashion. Instead, it is a key value pair. Amazon Textract extracts all these type of information from the document without requiring any configuration or templates. Let's see what Ryan Anderson, CEO of Filevine, which is a management software for legal professionals across the globe, has to say about Textract. Ryan thinks Textract is fast, accurate, and scalable. And Filevine has been successfully able to use Textract to serve the needs of sophisticated legal professionals across the globe. In fact, we are thrilled at the early adoption of Amazon Textract in the 6 months since we became generally available. Customers from various industries, be it healthcare, legal, financial, public sector, have been able to use Textract and build really cool applications with it. Later today, you will also hear Adrian, who's here from Change Healthcare, talk about their own Textract use case. We're also really encouraged by the vibrant ecosystem of partners, be it independent software vendors or system integrators that are helping customers meet their business objectives with Textract. All of these partners and customers are able to take benefit of Amazon Textract to extract text quickly, accurately, and retain the flexibility of working across various document types. They are able to reduce the amount of manual effort that had previously been spent on processing these documents. They have been able to reduce the cost their organizations had to incur in processing these documents, and they're able to do all of that without requiring any prior machine learning experience. So what's new in Amazon Textract since we launched 6 months ago? I can tell you that the team has been busy, and I'm excited to talk today about some of our quality updates and some functional improvements in the service. First, I want to talk about our Tables API. Here is a document with an embedded table. As we explained a few minutes ago, table is structured information that is organized into rigid rows and columns. What's exciting about Textract is you're able to extract these tables or this tabular information without having to define where in the document to find the table, how many rows and columns it has, where are its boundaries, etc. Now, this document, which looks simple at the first pass, is not really. First of all, the scan isn't perfect, the boundaries are not obvious, and before we evaluate how Textract does on this output, let's first think about how we would label this table. So a human being would label this table to have 6 rows and 7 columns. Now let's see how Textract does. The original output that you would have gotten from Textract 6 months ago would have correctly identified the table. But as you can see, it is not perfect. There are some additional rows and columns that have been inserted that did not need to be there. There is certain misalignment between column headers and cell values, and that occurred due to the complications of having merged cells within the table. With the quality update, now Textract gets it right. It has identified the table correctly. There are no extra columns or rows inserted, and the column headers are correctly assigned to the cell values. Let's look at another complex example. This is the same insurance form that we had peeked at a few minutes ago. You can clearly see that it has tabular information present. But which cell is aligned with which column is not immediately obvious unless you spend a lot of time on it. Here is how Textract used to identify this table. It identified both the primary tables, but it missed a section on the right. Now, Textract was right in determining that the section on the right doesn't really belong with the table on the left, but it did not identify the section on the right as a table in itself. And this is the best part about using a managed service like Amazon Textract. You can count on the continuous improvements that the service team is going to continue to make and see and rest assured that the underlying models that you use in your applications will continue to get better over time. Now, Textract identified both the tables more accurately and more completely. So within the same document, now Textract provides you more information. Next, I would like to talk about Textract's integration with Amazon's augmented artificial intelligence service that was announced in Andy's keynote earlier today. Augmented artificial intelligence, or Amazon A2I, as sometimes we call it, allows you to combine human judgment with the AI output. This allows you to apply nuanced human judgment when you see fit and still get the benefits of AI and machine learning. How is Amazon's augmented AI service used? Well, the first step is that you have to define the workflow. You have to define the business conditions that should trigger a human evaluation. You have to define who are the personas and the identities that will be doing the human evaluation. And then you need to define instructions or rules by which they will be reviewing your documents. The second step is to determine what kind of documents you want this human judgment to be applied to. Specifically, within Textract, you can set multiple business rules that will trigger a human evaluation. The first example is setting a business rule based on confidence score. Let's say you want to send your document for human evaluation if the confidence score threshold is below 90%. As a user, I know that the document I'm processing is complicated, and that if Textract provides a comparatively lower confidence score, then I might want a second pair of eyes on it. Send it for human evaluation. The second set of business conditions that you can set for human evaluation is based on important keys within your forms. Now, this is where you are able to take advantage of the knowledge you have a priori about your documents to specify that if a certain important key or a field is missing from the Textract output, then there must be something wrong, and it should be sent for human validation. As a user, I know that an adjusted gross income should be present in this form, so if it is not, it should be sent for human valuation. Lastly, you can use a random sampling of your document to be sent for human evaluation for your own QA purposes. And all of these thresholds and limits are customizable, so you can set these based on your use case. This is very powerful for some of our customers. Here is Chris from UK National Healthcare Service, who says that the combination of A2I and Textract has enabled NHS to actually take advantage of the power of machine learning for the first time, and that it is a game changer for them. I'm also excited to talk about some of our other functionalities in the recent past and the near future. On October 10th, we announced that Amazon Textract is now HIPAA eligible, which means that US healthcare businesses that have to comply with HIPAA regulation can now process their PHI or protected health information workloads on Amazon Textract. This was launched October 10th. Next week, we are also going to be increasing the file size limits of our synchronous API to 10 megabytes. Of course, you can also use our asynchronous API that offers a size of 500 megabytes apiece. And then we continue to expand our regional footprint. On Monday next week, we will launch Sydney in Northern California, making it a total of 7 regions that Amazon Textract is available in today, with more to come in the new year. Now let's take a peek under the hood of Amazon Textract and answer some of the questions that our customers ask us. They take their POC to development and then production. The first is how to make sense of the JSON output, because there's a lot of it. The output from Textract, which is in the JSON format, is extensive and covers a lot of information. As an example, the single page that you see here on the left has more than 22,000 lines in its JSON output. Now, this amount of information is very powerful for customers, so long as you know how to read it and make sense of it. Let's focus on the yellow section highlighted on the left here and the 32 lines corresponding to that yellow highlighted section. These are the same 32 lines from the previous slide, and let's see what is the different type of information that is represented here. The first is the content itself, the text and the numbers. In this case, the value is 54. Next is the confidence score associated with that content. And finally, we have the structure of the block type of the content, the relationship between various block types, and the geometry of that content within that page. Finally, within the structure is the block ID that establishes the relationship of that block with the rest of the page. Textract organizes its content into a hierarchy of block. There is one block per each content type. For text, the page is related to line, is related to word. For tables, the page is related to tables, is related to cell, and the cell is related to the words within it. And for forms, the page has key value pairs and the text associated with the key and value respectively. So within each block, you get the content, the relationships between the different blocks, and the geometry that allows you to locate it on the page. As powerful as the Textract JSON output is, our customers have asked us for a simpler output depending upon their need. So we have taken the JSON output from Textract and transformed it into providing 3 different types of simpler outputs that you can also use depending upon your application needs. The first is a simple text file that contains the words and numbers that were extracted by Textract. The second is a CSV file that contains the tables and the key value pairs that was extracted by Textract. And finally, you have what we call a searchable PDF, which is a flat image of your document superimposed with an invisible layer of text extracted by Textract. So when you do a Control F or a Command F, it finds and highlights the search string on the page itself. These scripts allow you to use Textract in a simpler way and use it within your applications. You can find these scripts in the link that is on the page or also on the QR code, which is on the bottom left. Now let's pause and talk about confidence scores. There's a lot of weight assigned to the confidence score, but we don't really spend a lot of time talking about what they mean and how they are derived. It turns out that the confidence score from Textract, which is assigned to each block type, ranges from 0 to 1 and is derived as a combination of signals from the multiple and various machine learning models that are at play. As an example, the confidence score associated with the word Textract is made up of the individual confidence scores of each characters that make up the word. What do these do? The confidence scores are designed in such a way to enable our customers to choose between a trade-off between the best precision and recall depending upon their use case. The customers can choose high precision, low recall, which means that less content is detected, but also means that there is less noise. Or they could choose the latter or the other alternative, which is lower precision, high recall, which means more content is detected, but there could be some noise. This trade-off is what is represented by the confidence score output by Amazon Textract. A higher confidence score means higher precision, means even though the content detected might be lower, there's also less noise. Or a lower confidence score means that more content is detected by contrast, but may have some noise. So this is how we intend you to interpret the confidence score. The confidence score, the way it is intended to be used also depends upon the content type it is associated with. So for text, the confidence score answers the question, was this content extracted accurately? And for structured entities like tables and key value pairs, the confidence score represents if Textract was able to correctly establish the relationship between these entities and identify its position on the page. Now, as promised, I'd like to invite Adrian on the stage and talk about how they are using Textract at Change Healthcare.
Thanks. Thanks, Kriti. All right. So as mentioned, I'm Adrian. I work at Change Healthcare as a lead data scientist. So healthcare is really expensive. I know you feel it. I feel it as well. And projections don't make it seem any better. In fact, it's expected to rise to approximately $6 trillion by 2027, or a fifth of our GDP. And out-of-pocket spending will also increase as well. To add on top of this, if you look at how much we spend per capita, the US spends fundamentally the most per human on healthcare. And we actually, if you look at rankings of healthcare, we are nowhere near the top. So fundamentally what's happening is that we spend more per person for worse healthcare. So now I know what you're thinking, why is healthcare so expensive? Fundamentally, we believe there's a lot of waste in the system. And this leads to extra costs. We estimate that to be about 30% or $1 trillion. Where is this waste coming from? Well, healthcare is still an exceptionally manual process. There's a lot of humans doing things that are very repetitive tasks. They're making suboptimal decisions as they're trying to navigate our healthcare system, which is really complex. So let me give you an example. I'll dive a little deeper into what's going on in the back end of the healthcare system. So if I get sick and I end up in the hospital for a few days, the hospital needs to write up what's called a medical claim. And that claim is what gets sent over to the payer, and that's how the hospital gets reimbursed for services rendered. Writing up that claim is a surprisingly complex process. They need someone specialized, someone called a DRG coder. And what their job is to do, they get to read my medical record, figure out all the diagnoses that were diagnosed during my stay, all the procedures that were done during my stay, and they need to code that up. So if I had pneumonia, they have to look that up. All right, maybe that's J189. It's basically a mapping problem. But it gets more difficult when you think of how many diagnoses there are out there. So it's a natural language processing problem into classification, but it's a 70,000 class problem. To add on top of that, Medicare comes out with updates every single year where it eliminates codes, adds codes, updates codes. The American Heart Association every quarter comes out with a coding clinic that says, hey, you can't use these codes this way anymore. So hopefully you're starting to see why, if we have humans doing this, they start making very suboptimal decisions. And the result of that comes out in increased time. It takes time for people to go through, look through these medical records, look up codes, understand all the information out there. It's increased cost. Your provider has to spend extra overhead just to get paid for things that they have done. And if someone does something wrong in the process, that claim comes back to the provider, and they have to rework that claim. It's called a denial. It's about at least $100 per claim that comes back, and that just leads to friction in the provider-payer relationship. So what can we do about this? So fundamentally, since we have humans doing all this work, we have data. And because we have data, we can start applying AI to all of this. So if we have machines up front, we can make accurate decisions first. With all this information we have, we can train AI to do the right thing. But AI isn't meant to be perfect. AI can't solve all problems, but it can solve a fair number of them. So we can have machines take care of the things that are very straightforward, very easy, things that we know are not complex, have them do it. And we can route the things that are more complex to humans. And we be smart about how we route things too. Maybe different employees have different specializations. We be intelligent about what kind of work we give to which people. And fundamentally, we're just hoping to reduce the number of rework that's being done. It sucks for hospitals to get denials because they just have to put in extra work just to get their money. So who are we? Who is Change Healthcare? So at Change Healthcare, we have about, I think, 100 offices across the US, 15,000 employees. We've been around for 20, 30 years doing this. In total, there's about $1 trillion in healthcare claims that we process per year, or 14 billion healthcare transactions. We see about 2/3 of the United States healthcare. So if you've been to the hospital twice in your life, there's probably a 90% chance that we had an effect on that network transaction for that claim. Another fun fact, if we just ceased to exist one day, the healthcare system would just come to a grinding halt. So we think we're in a pretty good position since we've built up relationships with those providers and payers and have started generating all this data to really apply AI. So I'm going to dive into a problem that we face, which is related to auditing medical records. So when medical records get submitted, payers are interested in auditing to look for fraud, waste, and abuse. But an audit requires validation of multiple elements. It's validation of the diagnosis codes that are there, the procedure codes that are there. The one I'm going to look at specifically are the itemized hospital bills, which need to be extracted from the medical record so auditors can actually go through and validate line by line that services were actually rendered. This is what it looks like. A couple examples of itemized bills, and you can start to see where Textract might come into the picture. So fundamentally, they look like tables. But there's a little bit of complexities that you might not notice from these tables. These are just 2 examples of iBills, but you can see they're pretty different formats. Some have just the line dividers, some have just the column dividers. Some are left aligned, some are right aligned. If you look really closely at the quantity and charge amount, it might be difficult to figure out where the edge of that column is. So we have all these itemized bills that are of varying structures in terms of what you might see for tables. And as mentioned before, it's currently an extremely manual process. We have an operations team that their sole job is to turn these tables into Excel files. It sounds ridiculous because it is. And they use a software. They go through, they try and detect tables. If they can't, they get to draw a bounding box over where that table is. They get to draw where the rows are. They get to draw where the columns are. And then they export it over to Excel. If any OCR errors come up, they get to fix that too. It's so, they have such a backlog that there's even a process. If you want your iBill extracted expedited, you have to go through a specialized process through them to get that done. Fundamentally, table extraction is actually a pretty hard problem. It's a two-part problem. The first part is where's the table, or table detection, and two, what does the table look like the structure? What are the rows? What are the columns? I've got a table up there on the left, and I know Kriti showed a couple examples as well. You can see some rows, they don't expand all the way over. Some columns don't expand all the way down. Maybe you'll have some empty rows as well. It's difficult. There's not that many data sets out there as well. There's one from Las Vegas, one from Washington, one from ICDAR. It's a document analysis conference, happens every other year, sorry. The last one was actually this year in Australia. That's about 20,000 images, 5,000 tables. We also have Table Bank, which seems like more. It's 400,000 tables. But those were Word document tables and LaTeX tables, so they're actually fitting a very specific schema. If you're thinking about scale in terms of what's a large data set, ImageNet is 14 million images. So this scale of data sets of tables, there's not a lot out there. We've gone through different approaches throughout the years for just historically what has been done. If you know what your table looks like, if there are certain features you can extract automatically, you know what the template is, you can just go with a rules-based approach, that's fine. There are other image processing techniques that can be done. There's a package called Camelot. It's open source. They look at PDF metadata, or they use image processing techniques like Huff transforms, which look at lines. So if your table has very distinct lines, it can start easily identifying where rows and columns are. And as you might imagine, it can go into deep learning. Table Bank has open source models of what it's done. It's not your just like Joe Smo model. They actually use state-of-the-art ImageNet models that have won competitions. They open source it. It's available to try. If you were at ICDAR this year, you might have heard of something called graph neural networks. Those are something really cool that have been really starting to explore in the document analysis space. It first came out, if you think about molecules, where you have like carbon atoms bounded to each other, it might not make sense as much to represent that as like a number, but more as a graph of things connected. And documents are the same way in terms of if you look at things across rows, things that are above and below each other, it's actually a little bit better to recognize documents and process them as graphs. And when it comes to tables, this makes a lot of sense. And this is basically where state-of-the-art is at. But fundamentally, it is still a very difficult problem. So where does Textract come into the problem? Well, Textract helps Change Healthcare really simplify this. Instead of going through any of the complexities, we get iBills. They're scanned in for us. They just drop them as PDFs. We use Textract, OCR, table extract, some minor data reformatting, and then it's just sent to the ops team for validation. So really streamlined process, very simple, very quick. Where does value come in? Well, I've used a couple different OCR technologies. In terms of text detection, so OCR is also sort of two-part, is detecting where's the text and then what is the text. In terms of text detection, it does a wonderful job. It's better than the ones I've used previously, so that's great. It helps structure very variably unstructured data. So data which you have tons of different formats, you might not know what it looks like. It helps us structure that for us automatically. Overall, it's helping us improve the efficiency of just everyday operations. It's making people's lives better and more manageable and just making them faster and happier. And we're hoping just it'll streamline the entire auditing process. So how do we continue to use this? What's down the line for us? Fundamentally, there are also different areas we can use this. So in other auditing areas, there's something called clinical validation. And in a clinical validation audit, we're looking at lab values and saying, hey, based on these lab values, in medical necessity, it says, if you have this lab value, you have this disease. If you don't have this lab value, it is not this diagnosis. So a lot of these lab values, if you've ever had like your blood drawn and you get the results back of like what are your white blood cells, your red blood cells, those often come back in tables. So we can use Textract to help us find those tables, automatically extract them, and format them for us. And fundamentally, after that, we can build models on top of those extracted lab values to just help us streamline, quicking the auditing process. We've found these values, we've confirmed this diagnosis, we can move on. So ultimately, our goal is to make healthcare faster, better, cheaper. It's a slogan our chief AI officer talks about a lot, and it's something I actively try and do every day. Healthcare, at its core, is still a very heavily manual process, and Amazon Textract helps make that easier. Medical records are messy, they come in all sorts of formats, and if you can structure that, that makes machine learning on it that much easier. And ultimately, we're just trying to build a better healthcare system. And that's the end of what I've got to present. Back to you, Kriti.
Thank you, Adrian. That was a great overview of the challenges faced by the US healthcare industry and how you are and what Change Healthcare is doing to help. Thank you so much. Now, wrapping up, I just want to leave you guys with a few messages. The first is that reading documents at scale is expensive and error-prone, and that you can use Amazon Textract to extract text and structured data, table and key value pairs from virtually any document without requiring any configuration or any templates. You can use Amazon Textract to extract data quickly and accurately with flexibility across different document types, reduce any manual effort you have to put in, lower your processing costs for document processing, and do all of this without requiring any significant machine learning experience. We talked a little bit about some of the quality and the feature updates that the team has been working on. And my final thought is that getting started with Textract is really easy. I encourage all of you to go to our console, upload a document, and see what Textract is able to retrieve for you. Thank you so much for your time today. I will be hanging out here with Adrian at the side in case any of you want to come up and chat. And please don't forget to leave the feedback in the mobile app. Thank you.